Number 10, a 1,000 kilograms automobile is at rest at a traffic signal. At the instant the light turns green, the automobile starts to move with a constant acceleration of 4 meters per square second. At the same instant, a 2,000 kilograms truck traveling at a constant speed of 8 meters per second overtakes and passes the automobile. Letter A. How far is the center of mass of the automobile truck system from the traffic light at t equals to 3 seconds? Letter B. What is the speed of the center of mass then? Okay, so this is the traffic lights, right? So we have green over here, we have red and green. So let's say this is the origin of our coordinate system. So this is x equals to 0. And then we have a automobile that goes this direction and a truck that goes to the same direction. Okay, so the thing that we have to do here is to find their position and then calculate the center of mass. Okay, for the red car, remember that the acceleration is constant in both cases. For the car, the acceleration is 4 meters per square second, and for the truck, the acceleration is 0, but it's constant as well. And when the acceleration is constant, we can use this equation over here. X equals to xo plus VOT plus AT squared over 2. So for the red car, its position, the initial position is 0, right? So this term goes away. Its initial speed is 0 as well. So it is equals to AT squared over 2, its position. Okay, the acceleration is 4. T is equal to 3 seconds. So over 2, so this is equal to 18 meters, right? So that's the position of the car after 3 seconds. For the truck, let's call it x2. So the initial position of the truck is 0 as well. Its acceleration is 0. So this is the only term left. So VOT. The speed of the truck is 8. T is equal to 3. So this is equal to 24 meters. So those are the positions of the car and the truck. The position of the center of mass is 1 of the sum of the masses times the sum of I equals to 1 until n of MIXI. So this is equal to the sum of the masses, which is 1,000 plus 2,000, which equals to 3,000, times the mass of the car, which is 1,000, times its position, 18, plus the mass of the truck, which is 2,000, times its position, which is 24 meters. And this gives us 22 meters. Okay, so that's the answer of letter A. For letter B, we want the speed of the center of mass. So let us rewrite this equation as a generic equation. So the position of the center of mass is equal to 1 over, let's call it m1 plus m2 times m1, the position of the first one, plus m2, the position of the second one, right? If we want the speed of the center of mass, all we have to do is take the derivative of the position in respect with time. So take the derivative. The only thing that's not constant, it's their positions. So this is going to be 1 over m1 plus m2 times m1 dx1 over dt plus m2 dx2 over dt. And you can notice that this term over here was rather okay, so this is the speed of the car and this is the speed of the truck. So we just found that the speed of the center of mass is equal to 1 over the sum of the masses times m1 v1 plus m2 v2. So we just need to find the speed of the car and the speed of the truck, and then we can complete our calculations over here. So if the acceleration is constant, the speed of the cars is given, the car and the truck is given by VO plus AT. So the speed of the car is equal to its initial speed, which is 0, plus the acceleration, which is 4 times 3. This gives us 12 meters per second. And the speed of the truck, it's constant, which is equals to 8. So this would be equal to 1 over the sum of the masses, which are 3000, times m1, which is 1000. The speed of the car is 12, plus the mass of the truck, which is 2000, times its speed, which is 8. And this gives us 9.3 meters per second, and that's the answer of this exercise.